There are two special functions in MATLAB that allow us to translate a matrix into a set of logical scalars or a vector into a single logical scalars. Those functions are the any and all functions. The any function is designed to determine if any element within an input array is non-zero. In contrast, the all function is designed to determine if all elements within an input array are non-zero. Let's see how we can use these to test non-zero-ness of individual elements of an array and also shrink an entire m by n matrix into a single logical scalar. With that, we're in the command window and we'll write our first bit of code. So what we're going to do is define a vector. We'll use the rand_i function. Remember, rand_i means random integer. The first entry of this function gives us the upper bound. So in this case, we're going to say we want every entry of x to be a random integer between the number 1 and the number 20. And we're going to say that this is a 10 by 1 vector. Now we can run a test and ask which of these entries are, let's say, above 18. So if we run the test, look at x and produce which entry is above 18, notice there should be 1 in entry 2, 1 in entry 4, and then 1 in the final two entries, which is exactly what we see. And then if we ask ourselves, hey, is any of these test values non-zero? Oops, MATLAB produced a error here, and the reason it produced an error is because I used the variable text, not test. So let's go ahead and just change this, and why don't we just call it test1, because test seems to be used in one of the toolbox. So here we go, and then we'll see, is any of those tests non-zero? Indeed, at least one of those is non-zero. Similarly, if I said, are all of the tests non-zero, MATLAB produces a 0, meaning that it's false. In other words, not all test values are non-zero. We could, of course, run a different test. Let's call it test2. What if we were to say, let's look at the values of x that are above 0. So when I run that thing, notice that all of the values of x are non-zero, and that's because the rand_i function produces pseudo-random integers between 1 and 0. Indeed, when we look at that vector, all of those values are above 0. Now if I typed in all of test2, question, are all the test2 equal to 1? Indeed, that is true, so MATLAB is producing a true value there. What we've just seen about the any and all functions is if we put in an m by 1 input vector, that's a column vector with m inputs, that the output size for those functions are a 1 by 1 logical scalar. And particularly, we're asking ourselves, are any of those entries non-zero? If that's true, we produce a true for the any function. In the all function, we ask, are all of the entries non-zero? And if that's true, we produce a logical true value. If not, both of those become logical false. We could, of course, also do logical row vectors as the input to these functions. Logical row vectors takes a 1 by n row and reduces down to a 1 by 1 vector. I'll let you viewers at home try that for yourself. Simply run the same test, but instead of a 10 by 1, try a 1 by 10 with different conditions, obviously. And then the last situation is if we have an m by n matrix, we can input those to the all and any function to produce a 1 by n row vector. Let's go ahead and see how that works out. So we'll clear all of this, clear the screen. Let's go ahead and set the matrix A. We'll say that it's a 25 random I integers, a pseudo-random integer valued matrix. The values run from 1 to 25. And let's go ahead and set this to be a 5 by 3 matrix. So now we have something that looks like this. Notice that by definition, these values run from 1 to 25. Let's suppose that we want to shift those down by 1 less than the minimum. So here we'll say that this is 3 times 1s. And of course, when we run this, we're going to actually call a different value. So every time that we run the rand_i function, we produce a different matrix, and we're shifting all the values down by 3 basically. And then the really cool thing about this is that we can run a test which of the values are below 0, and we see that 3 of those values are below 0. And of course we could ask ourselves, are any of these values in A less than 0? What MATLAB does is actually process the individual entries of each column individually. So in the first situation, it asks, are any of the entries in, let's see, column 1 non-zero? MATLAB tests all of those entries and produces a false. In other words, none of those are non-zero. Same thing, moves over to column 2, produces, are any of the entries in column 2 non-zero? Well, we see 1, 2 are non-zero. In other words, there are at least exactly two negative entries in column 2 of A. And then the same thing in column 3. We produce all of column 3. MATLAB asks, are any of these negative? The last one is negative here, and it says, yes, one of those is negative. In other words, we've compressed a 5 by 3 into a 1 by 3, where the results, the true or false results, are done column by column. We could ask the same thing, are all of the entries in a particular column less than 0? Notice that is false, false, and false, because not all the entries in the first column are negative, not all the entries in the second column are negative, and the same is false about the third one, or true about the third one. Not all are negative. That's why we get this. Notice that if we ran any twice, so any, and what did we say? A was less than 0. We actually compress a 5 by 3 matrix into a 1 by 1 logical scalar. And the question that we're asking is, the first run of any produces this vector, and then the second run of any, so basically I say any less than 0, and then I take that logical vector and I put it into the any function. So now this is false. Logical, and then what do we say? 0, 1, 1. So I'm going to go ahead and typecast that as logical. And what MATLAB does in the second call to any is actually test each of the individual entries, and we notice that at least one of those is non-zero, and we produce a true value because at least one of them is non-zero. The same thing is true with all. If I run 2 alls here, and then I say A less than 0, notice that it compresses the entire matrix that we started with down to a single logical scalar, and the truth value of that logical scalar is that not all of the values of these things are less than 0. With that, let's clear our screen. I'll go ahead and remind you the best way to learn about these is actually to go to the documentation and actually read about the any and all functions. You can do that by just typing help any or help all. You'll get a really good description of the syntax to be used, as well as a description and some examples of code that you can run. We will use the any and all function later in lessons 4 and 5 when we're talking about branching statements, in other words, if-else statements. This is a great way to transform array-based data into logical scalars so that we can check conditions on all elements of an array or any element of an array at one time. And then we'll also use it when we're coding up functions to test whether or not certain things are true on the entire array at once and turn it into a single logical scalar. With that, I pose the community challenge for this video. Think about some different mathematical operations where you would want to test the entire set of array elements to figure out whether or not something was true, and how you could use that in computer programming that we've talked about thus far. Thank you so much for your attention, y'all, and I'll see you in the next video.